The cranes never sleep. They lift, swing, and place containers at a pace no human crew could match, around the clock, every day, without a single coffee break or shift change. And the port running on this system just crossed 5,000 tons of cargo moved per day, with a workforce on the docks that rounds to zero. That is not a marketing claim. That is the operational reality of what China has built on its coastline over the last decade. And the countries watching it happen are asking a question that has no comfortable answer. What do you do when your competitor removes the most expensive variable from the entire equation? Stay for that, because by the end of this, the number that will stick with you is not the 5,000 tons. It is the number of workers it used to take to move that same load, and what happened to that workforce overnight. But first, you need to understand how we got here, because this did not start with robots. It started with a problem that every major port in the world was quietly ignoring. Container terminals are, by design, chaos. You have vessels arriving on tides, trucks queuing on land, cranes that need operators, and stacking yards that are essentially three-dimensional puzzles solved by humans under time pressure. The margin for error is small. The cost of a delay, measured across a vessel carrying 14,000 containers, runs into the hundreds of thousands of dollars per day. Ports in Rotterdam, Los Angeles, Singapore, they all threw more labor at the problem. More operators, more coordinators, more bodies. China looked at the same problem and asked a different question. Not how do we add more people, but how do we remove the bottleneck entirely? The answer they built is called an automated container terminal, and the version operating right now at Qingdao Port on the Yellow Sea coast is one of the most advanced logistics machines ever assembled. Here is what that actually means on the ground. The quayside cranes, the massive steel structures that lift containers from ships, are controlled remotely from an operations center. Not operated in real time by a human every second, but supervised. The crane reads the ship's manifest, locates the container by its identification code, lifts it, and places it on an automated guided vehicle waiting below. The vehicle, which runs on a track system and never needs a driver, moves the container to the stacking yard. There, another automated crane, a rail-mounted gantry, picks it up and places it in the exact position calculated by the terminal's AI to minimize retrieval time later. When a truck arrives to collect that container, the system already knows its license plate, its booking window, and which stack position holds its cargo. The container comes down, the truck loads, the truck leaves. No human touched the box from the moment it came off the vessel to the moment it was placed on that truck. The speed this produces is not incremental. Traditional terminals measure their efficiency in what the industry calls crane moves per hour. A well-run conventional terminal with experienced operators hits around 25 to 28 moves. Qingdao's automated quayside cranes have recorded sustained rates above 60 moves per hour. That is not a peak number grabbed for a press release. That is the sustained operational figure over verified shifts. But here is the part almost nobody talks about. The 60 moves per hour figure is impressive in isolation. What it means geopolitically is something different. Every major export economy runs through ports. The total cost of moving a container from factory floor to foreign retailer is not just the shipping rate, it is the dwell time, the handling charge, the labor surcharge, the demurrage when a ship waits. When you automate the terminal at the level China has, you compress multiple line items simultaneously. You reduce handling cost, you compress dwell time, you eliminate the labor rate entirely from those operations. You are not just building a faster port. You are repricing the cost of exporting from your country versus exporting from someone else's. And the countries that have not made this transition yet are now competing against a port that has structurally lower operating costs baked into every single container it touches. To put this in physical terms, the Qingdao Automated Terminal's stacking yard is large enough that if you laid the cranes end to end, they would stretch further than the length of 16 football fields. The automated guided vehicles run on paths so precisely engineered that their positioning tolerance is measured in centimeters, not meters. The whole system is coordinated by a platform developed domestically in China, which means the software stack is not licensed from a European or American vendor. The operational data, the optimization algorithms, the routing intelligence, all of it sits inside the system China built and controls. That last detail is the one that keeps logistics analysts in Western capitals quietly uncomfortable. Here is the twist. Qingdao is not the only installation. Tianjin has one. Shanghai's Yangshan terminal, already the busiest container port in the world by volume, has been integrating automation into its Phase 4 expansion. Guangzhou has a facility running on similar principles. What started as a pilot project at one port is now replicating across the country's entire coastal logistics chain, terminal by terminal. The scale of that rollout is what separates this from a technology showcase. A showcase you can watch and decide not to copy. A nationwide rollout at this pace changes the baseline that every competitor must match just to stay in the same race. And the race, it turns out, is not just about cargo. The port automation system China built does something that purely commercial efficiency arguments tend to understate. It generates data. Every container movement, every vehicle routing decision, every crane cycle, every truck arrival is logged, time-stamped, and fed back into the optimization model. Over months, the system learns the rhythms of the terminal, the patterns of which shipping lines run, which schedules, which cargo types cluster, at which times of year, where the bottlenecks form under weather stress. It builds a predictive model of its own operation. That model has value beyond the terminal it was trained on. It is a commercial intelligence asset. And because the platform was developed domestically, that asset does not leave the country when the vendor pays its quarterly licensing fee. Compare that to the situation at ports in Europe and the United States that have purchased automation components from various suppliers over the years. Rotterdam uses systems from multiple international vendors. Several West Coast American ports have stalled automation projects due to labor agreements, regulatory timelines, and procurement disputes. Los Angeles, the busiest container port in the United States, has run conversations about automation for years. The implementation has moved slowly. The reasons are structural, not technological. Union contracts, municipal politics, environmental review processes that take longer than it took China to design and build some of these terminals from the ground up. The gap this creates is not theoretical. It is operational. Today, right now, the throughput efficiency difference between the leading automated Chinese terminals and a comparable conventional Western port is measurable in dollar costs per container moved. Multiply that difference by millions of containers per year, and it translates into a structural trade cost advantage that compounds every quarter. The countries that understand this are moving. South Korea has been expanding automated operations at Busan. Singapore, which has been running some level of terminal automation for years, is building a new port at Tuas, designed from the foundation up as a fully automated facility, projected to be the largest automated port in the world when complete. Germany is investing in automation infrastructure at Hamburg. The field is not standing still, but the distance between the leaders and the middle of the pack grew while the debate was still happening. And it gets crazier. The 5,000 tons per day figure in the operational data for these facilities is a daily average across the full 24-hour cycle, not a peak window pulled from the best shift of the month. That consistency is actually harder to achieve than the peak number. Conventional terminals have good shifts and bad shifts, depending on crew, weather, vessel arrival patterns. Automated systems run at a flatter, higher baseline. The ceiling is lower than a perfect human-operated day, but the floor is dramatically higher than a bad one. And in logistics, it is the floor that costs you money. What this means for global shipping is that the reliability of China's automated ports has started to factor into routing decisions. Shipping lines, when they are choosing which ports to call on a given route, weigh transit time, handling cost, and schedule reliability. A port that consistently delivers containers to trucks within a predictable window is worth more to a shipping line than a faster port with variable performance. The automated terminals have been building a reputation for schedule reliability that is becoming a commercial draw independent of the cost argument. That is how infrastructure becomes leverage. Not through a single dramatic announcement, but through the quiet accumulation of better numbers quarter after quarter, until the choice of where to route your cargo has been shaped by the infrastructure that already exists. None of this happened by accident. The investment in port automation in China tracks back to state planning decisions made more than a decade ago, when the leadership identified logistics infrastructure as a strategic bottleneck and began funding the development of domestic automation technology rather than purchasing it from abroad. The first pilots were expensive and imperfect. The cranes broke down. The software had routing failures. The automated vehicles had positioning errors. Engineers worked through those failures, documented them, updated the systems, and ran the next iteration. The current generation of terminals is the result of that iterative process, which means the institutional knowledge of how to build and run these systems is now embedded inside Chinese engineering firms, software developers, and port operators. That knowledge is itself an export. Several ports in Southeast Asia and along the routes connected to Chinese trade have received investment and technical assistance to build similar infrastructure. When a port in another country runs on a system designed, installed, and maintained by Chinese firms, the relationship between those ports is not just commercial, it is technical and operational. The data flows, the upgrade cycles, the support contracts, all of that creates a durable connection between the operator and the system provider. You are looking, in other words, at a logistics network that is not just faster than what it replaced. It is structurally connected in ways that conventional port competition was not designed to account for. Here's where the 5,000 tons number lands with its full weight. 5,000 tons per day, every day, without a human hand on the dock, is a proof of concept that has already scaled. It is not a demonstration project awaiting a business case. The business case ran. The numbers came back positive. The technology is in production at multiple facilities simultaneously. And the gap between the countries that are replicating this and the countries that are still reviewing environmental impact assessments for their first automated stacker is not closing on its own. The port that never sleeps is not science fiction. It is operating right now, moving cargo that will be in stores in other countries within weeks. The workers who used to move that cargo are not coming back to those jobs. The countries building the next generation of these facilities have already absorbed that lesson and moved past it. The question this leaves open is not whether automated ports are the future. That answer is settled. The question is who builds them, who runs them, who owns the software layer, and who gets the routing contracts when the shipping lines make their next round of decisions. That is what is actually being decided, one container at a time, at a terminal where the cranes never sleep and no one punches a clock. If you want to see what the rest of the world is building next, this is the place to be.